Now what we need to discuss is the concept of a function closure. Now I have covered this topic in JavaScript Basics, the first course in this JavaScript series. However, I want to give you some further information about closures in the context of functional programming. So first thing that we need to know is that a function creates a new closure, or rather a closure is created with each new function that we declare. Now the clever thing with a closure is that it simply gives us access to the outer function scope even after our outer function has perhaps returned. So what do we mean by this? Now to understand closures is the first part of our journey, and we want to do this because I want to introduce you to more advanced concepts such as higher order functions as well as currying, which is more of an advanced functional programming practice that we'll come on to later in this chapter and is absolutely my favorite part of functional programming. But before we can get there, we need to understand a function closure. So let's go ahead and create another constant. Now, because we are discussing these things such as lambda expressions, I actually prefer using a const instead of something like a function keyword because it allows me to compose my functions and treat them as more of a lambda expression. So instead of using function, we're going to use const. Now, what we're going to do is say get the name from the ID and then simply assign it an arrow function. Inside the arrow function, we're then going to return another function, and by doing so we can now understand the concept of a closure. So what we're going to do is take our get name from ID and we're going to call the function underneath. So here I'm going to pass in our first ID. So we're going to pass in a string value. You can pick whichever one of these you want. I'm going to go for some fries and we're going to pass it in like so. Now at the moment the function doesn't really do anything. We need to obviously pass in our ID. So once we've done that, we can in fact dive in, we can say console log and give me the ID. Now this return is going to return, however, we're not doing anything. So the return value of our function call here is in fact going to give us a new function. So what we're going to do is create another constant here, and we're going to say get the fries equals, and then get name from ID. So if we also go ahead and log out our get fries, we can save things out. You can see that line 17 is a function, line 16 is our initial array. But the interesting piece is our line number 10 console log, which you can see inside index.js is our fries emoji. This function here is exactly what we have available to us with this getFries constant. Now because it's a function, we can actually call it and pass in our items. So we'll eradicate our above console log and we'll just save this out. So at the moment we can now see undefined. We do not have our response back from our get fries because we're not returning anything inside of here. Now just to give you an example, if we were to return a string of ABC, you can see that we now have ABC. So what's happening is we have a function, we call the function, we return a new function, which then we call here. So there's just a function within inside a function. That's all that's happening. Now the interesting piece is instead of returning ABC, we might want to actually do something more important. And by understanding these closures, we can then start to understand the concept of a higher order function, which we're going to cover in the next video. And that will then lead us into currying and more advanced functional programming practices. So this is really nice. Make sure you understand this before we continue any further. So instead of returning ABC, the reason that I'm doing this is because we want to get the name of the particular item from its ID. We're then passing in our items because remember we want to keep our functions nice and pure. So there's no references inside of here. At the moment we have an impure function because we are simply using a side effect of console log. However, we don't really need to use that anymore. Now the magic happens here because we've called our function once, we now have access to the ID inside this function. So instead of returning ABC, we're going to have a look at the arguments because we're going to get given the items. So here I'm going to say console log, first we want to look at the ID, and secondly we want to look at the items. Now you may be thinking, why are we logging the ID in here? A minute ago we were just logging the ID here. Now what I said at the beginning is a closure is created with every new function. So we have one closure here and we have a second closure here. The inner function, so our function here, still has access to any variables in this particular scope. So what that means is even though we've returned, the lifecycle of this function is still alive in our program, which means we have access to our ID in further function calls such as this. So now what we can do, because we want to get the name from the ID, we can say return me the items, and we're going to use array prototype find here. We then get each individual item, and here's the clever part. We can say I want to find any item IDs that match our ID passed in above. So what this is doing is taking our ID, which is our fries, we're then passing in an array, we're then finding a particular item that matches this expression. If any of these items IDs do in fact match the ID that we've passed in, then we're going to simply return that single item. Now if I save this out, we will in fact see an entire object in the console. So we don't want an entire object because we want to get the name. Now thankfully, array find returns us the single item. If we were to use array filter, it might actually return us more than one result. However, it returns us an array with those results in. So using find here would be the more appropriate choice. We can then, because we're finding that object, is we can just look at that .name property. So we'll save this, and we now have our jumbo fries being printed out in the console. If, for example, we take the burger, we could change this, save this out, and again, it goes and finds that correct one. So this is the benefits of using a closure. And in doing so, we've learned how to create what we call a higher order function. So here, our getName from ID is acting as a higher order function because it returns us a new function that we would repeat perhaps several different times. And the reason that this is a nice reusable function is because we have one data set here as our items, but it might be that we have a completely different array and so forth with lots of different items inside. However, we might have just one ID that we're looking for in perhaps multiple arrays. So that's just giving you a bit of an exploration as to what a closure can do for us. Now I mentioned at the beginning that we like to use the const keyword because this acts as a kind of lambda expression which we've learned about just previously. Now one thing I like to do, as many of us like to do, is refactor these to a nice one-liner to make things nice and clear. What's also nice is that we can use implicit returns and make our function look like a nice lambda expression. And I would call this a nice lambda expression because it doesn't have a name, things are created anonymously, and we have an expression within a function closure. So this is typically a style that we'll use to compose lots of functional programming software. So that's it for this video. I hope you really enjoyed understanding more about function closures in a functional programming context. We've just learned how to create a higher order function as we've just described, but there's more to higher order functions than simply just returning another function. So in the next video, we're going to learn a little bit more about why we should start looking at these closures and higher order functions, because what they in fact do is offer us lots of flexibility. For example, we could say that we want to get the burgers. We could then duplicate our console log, replace our get fries with get burgers. We can save things out. So here we can pass in our ID as before, and we can call this as many times as we like, and we get each item back. So that's the benefits of closures. We've learned about higher order functions. We've then refactored over to a lambda expression, and things are looking nice and clean. So that's it for this video, and I'll see you in the next one.